Hello, this is Ms. Martin, and this is notes for Chapter 3. We were talking about matter and properties, matter and its properties and changes. Everything is in the PowerPoint that you can find online, but there are a couple of things that we need to work out, so that's what I'm going to do. So we're going to skip down. So these are all the notes. These are all filled in for you. All you have to do is read through them. The only thing that I did not fill in, because in class we actually went over it, but if you missed class, then let's talk about the couple of things in this chapter where you are going to have to actually do math. One thing I did want to say is that right here, this phase diagram where it's talking about the different phase changes is not in your notes, but it would be extremely helpful for you to know all of these, and extremely beneficial for you to know all these, and you can draw this on the back of your notes so you know all those different phase changes. So what we want to be looking at is, the first thing is law of conservation of mass. And so law of conservation of mass says that mass cannot be created or destroyed. It has to be conserved. And so the mass of the reactants is always going to be equal to the mass of the products. So what we want to do is we want to look at this question right here. So it talks about conservation of mass and how we're going to see conservation of mass and how we show that using a little bit of math. So we're going to look at this question. So it says that we have an experiment. We have 10 grams of red mercury oxide powder is placed in an open flask, and it's heated until it's converted into liquid mercury and oxygen gas. This is what's called a decomposition reaction. We're going to see in just a second that we have a compound and it's being broken down into the components, or into the elements. It gives us the mass of the liquid mercury, and it's asking us what is the mass of the oxygen. So we want to take this, and the first thing we want to do is write out a basic reaction. So I'm going to start by writing out, so we're going to have mercury oxide, that's the starting point. So it says it has red mercury, and this little 2 right here is not really important for us right now. We just know that this right here is a compound. So it is 2 elements that have been bonded together, and it is a compound. And it is placed in an open flask and heated until it's converted. So that saying converted means that we're reacting. It's reacting, and it is actually breaking down. And so we're breaking down into mercury plus oxygen. Okay. So when you do this, when you actually write out a reaction like this is called a chemical reaction. Later on in the year, we will get to the point where we are talking about chemical equations and actually writing them out with symbols and numbers and balancing them and going through that process. But for right now, just writing the words is actually helpful because it helps us to see kind of what's happening here. And we need to focus on this arrow right here. This arrow is the place where the chemical reaction is taking place. There is a chemical change happening, and you're going from having a compound in the mercury oxide to having 2 elements, the mercury and the oxygen. So the left side of the arrow, these are called the reactants. In this case, we only have 1 of them, so that's the reactant. On the right side of the arrow, we have the product. So we have reactant, we have product. In this case, we have 2 products. It doesn't matter how many you have. I could have 2 reactants, 1 product. I could have 3 reactants, 1 product. I could have 2 reactants, 2 products. There's lots of different combinations here, and so don't think that it has to be just one thing. So let's talk about what we're dealing with as far as our numbers go. It tells me that we have 10 grams to start off with of my mercury oxide, and then it's producing 9.26 grams of the mercury, and then the question is, how much oxygen is there? And so when we talk about this, if we think about this and look back for just a second to our formula here, it's the mass of the reactants should be equal to the mass of the products. So if we think about this like a math problem, and instead of putting a question mark right there, let's put an X in. So now we have, say we have an X. And we know that the mass of the reactant has to equal the mass of the product. So then it becomes a very simple math problem. All we're doing is basically solving for X. And so when we do that, we're going to subtract the 9.26 from both sides so that we can cancel that out and get X by itself. And then we can see that the mass of the oxygen is equal to 0.74 grams. So all we're doing is just solving for one missing part of that reaction. This is how your problems are going to be on homework number 2. So if you go to look at homework number 2, you're going to see that they're very similar to this. There are some questions on there that you have to ask about mass of the reactants, mass of the products, but it all comes back down to this, that the mass of the reactants has to equal the mass of the product. And really and truthfully, when you think about it, it should say that the mass of the total reactants has to equal the mass of the total product. So if we have 2 products, we have to add them together. If we have 2 reactants, we have to add them together before we set anything equal to each other. Okay? The other part that we need to look at, the other math involved in this unit, is going to be when we talk about law of definite proportions. So both of the calculations that you have to do with laws. So there was law of conservation of mass, and then we're going to look at law of definite proportions. So let's look at law of definite proportions. So law of definite proportions says that a compound is always composed of the same elements in the same proportion by mass, no matter how large or small the sample. Percent by mass, which is what we're going to be calculating, is the ratio of the mass of each element to the total mass of the compound expressed as a percentage. And this is the formula that we use. So mass of the element divided by mass of the compound times 100. So what we want to do is there are 2 questions at the very end of the notes, and that's what we want to look at. So we're going to take each one of these questions, so there's one there and one here, and we're going to set them up, and I'm going to show you how to solve to find the percentages. So we're finding percent by mass for each of the elements. So it tells us that we have granulated sugar, and it contains 8.44 grams of carbon, 1.30 grams of hydrogen, and 10.26 grams of oxygen. So those are the 3 things that this contains. And then we want to look at what is the percent by mass for each of the elements. So I'm going to take this and I am going to work with carbon first. So I'm just going to set up a little equation here. So the carbon is 8.44 grams. Over the mass of the compound is 20 grams. Now in sometimes you are not given this 20 grams. If you are not given that 20 grams for your total, then what you can do is add up all of the grams of the element, and then that can give you your total for your compound. So like in this case, it does say 20 grams for the granulated sugar, but if you didn't have that, then you would take each of the individual elements, add it together, and that will give you 20 grams. Okay, so we're going to multiply by 100 because we're going to try to get this to be a percentage, and then we would get our percentage. And so if you do this, if you calculate this and then look at significant figures, this has 3 sig figs, this has 3 sig figs, and so my answer should have 3 sig figs. And so this would be 42.2%. Okay, for hydrogen, we're going to do the exact same thing. So we're going to go 1.30 grams over 20.0 grams, multiply that by 100, and then we would get 6.50 grams, or sorry, 6.50%. For the oxygen, we have 10 0.26 grams over 20 grams. Multiply that by 100, and we're going to get 51.3%. Okay? Now, the thing about this, when you're dealing with percentages, is that if you are wondering if you've done this correctly, if you want to double check yourself, if you want to say, okay, did I make a mistake in my calculator? When you're working with these percentages, if you add them up, they should equal 100. So the percents should equal 100. And they should be very, very close to 100. If, for some reason, because of rounding, it's off a little bit, maybe it's like 100.1 or 99.99, that's usually okay. But we don't want it really off. Like if you added them together and got 75 or 90, that's not right. So we want to look at it and say, okay, did we put the numbers in the calculator right? Did we set it up right? And so that's where you can see that it is added up correctly. So in this case, we have the same substance. So it's still sugar. It's going to be the same granulated sugar that we saw in the previous substance. What I'm trying to show you here is that law of definite proportions says that it doesn't matter how big your sample is, as long as it's the same substance, your percentages should add up to be the same. And so that's what we want to look at. We're going to do another example, and it's the same substance. So I want to prove to you that it's going to end up with the same percentages. So we're going to do the exact same thing we just did. Let's set this up. So we're going to look at carbon, hydrogen, and oxygen. So we're going to do carbon, hydrogen, oxygen. Okay, so for carbon, we have 211 grams over 500 grams. Multiply that by 100. Oops. And so if you divide that, you're going to get that this is 42.2, and I missed a sig fig here, so it should be 4 significant figures. So let me divide this again real quick, and we will. So that's what it gives me is 42.2, and so we're going to put a 0 on there so that we have the right number of sig figs. This has 4 sig figs, this has 4 sig figs, so my answer should have 4. Okay, so let's do the next one. So we have 32.5 grams divided by 500 grams. Multiply that by 100, and we're going to get 6.500%. Okay, and then the last one, we have 265.5 divided by 500, forgot my grams, times 100. And so if we do this, we're going to divide that. And we're going to get 51.30%. Same exact percentage. It is the same percentage, and so you can see that they are the same. So substances, no matter how big the sample, if they are the same substance, the same compound, then the percentages should end up being the same. Okay, so really quickly, let's talk about the homework packet. So this is the on-level homework packet. If you're in pre-AP, if you'll just fast forward just a little bit, I'll talk to you about your packet as well. But for the on-level homework packet, if you go all the way down to homework number 4, there are 2 questions that have moles in them, and we haven't talked about moles. This was an accident, and so we need to change these to grams so that you can do this problem. So let's do that. So let's change these. Let me tell you what you're going to change them to. So on number 4, we're going to take this and we're going to cancel out, or just mark out that 1.2 moles, and we're going to put 14.4 grams. For the hydrogen, this is going to be 3.23 grams. So you're going to change those, and then you're going to do basically what I just did with the calculations of doing percent by mass. Okay, Same thing on number 5. Let's change these. So we're going to cancel that out. We're going to change this to 2.80 grams. And then for sulfur, it's going to be 1.60 grams. Okay, so for on level, you do not have to be able to go from moles to grams or anything like that right now. Okay, that is not part of what you're doing. We will learn that later. Okay, if you are on level, you can turn off the video right now. The rest of the video is going to be for pre-AP. So if you're in pre-AP, then let's go ahead and look at your homework packet. So for pre-AP, you should be able to go from, or you should have a little bit of an idea about how to go from moles to grams. And so what we want to do is we want to look at these last problems on the homework, and I'm going to go ahead and do number 4 with you. That way you have that and you can be more comfortable with that. So when you're dealing with moles, maybe that's going to throw you off a little bit. So let's go ahead and do number 4. So let me show you how to set it up, and then we'll go all the way to percent composition. So let's look at number 4. So in number 4, we have to get this moles to grams before we can do anything else with it. So I'm going to take this and I am going to set this up so you can go from moles to grams. So for carbon, so we're going to take carbon and we're going to do 1.2 moles over 1. So what we're going to have to do is we're going to have to do a dimensional analysis to get it to grams. And so let me show you how we do this. So we put 1 mole at the bottom. And then this top portion right here actually comes from the periodic table. So if you look at your periodic table, you're going to see that on your periodic table, it tells you the mass of carbon on the periodic table, which is the number with the decimal place. And so it's going to be 12.01 grams. Actually, that's supposed to be 12.011. Okay, so if you look at your periodic table, I'm looking at this number right here. So this bottom number right here, which represents what's called the atomic mass, that is the number of grams in 1 mole of any element. So all of these, each of the elements has that number. So that's what we're going to do. So we're going to go from 1.2 moles, and we're going to multiply by the grams so that we can get the number of grams. Okay, so I'm going to, because if you think about it, moles will cancel out, you'll be left with grams. So if I do that, so if I say 1.2 times 12.011, I'm going to get 14.4. Now, I am going to tell you that, honestly, this homework should have had an extra 0 right here. Because if we just take 14, that's not going to give us really great information. So I'm going to take another sig fig. I will make sure in the future that you've got at least 3 sig figs to work with, if not 4, because that's going to make things a little better. So I'm going to tell you it's okay. We're going to take 3 sig figs. Okay, so there we've got that. Okay, now let's do the exact same thing with our hydrogen. So hydrogen, we got 3.2 moles over 1. And then we're going to do the same thing. We're going to look for hydrogen on our periodic table, which is over here. It's 1.008. So I've got, 1.008 grams, 1 mole. And like I said, probably best to take 3 sig figs on all of these. I know that it just has 2 in the problems. Go ahead and take 3 sig figs when you're doing grams. And like I said, I'll make sure in the future that it's got the right number. Okay? Okay, so this is going to be, 3. Oh, that's ugly. Let's change that. 3.23 grams. Okay? So what I need to do now is from here on out, I can do the calculations like we were talking about, where you're going to take, and this is the mass of the element. We want to divide by the mass of the compound. And so in this case, it doesn't give us the mass of the compound. So what we're going to have to do is we're going to have to add this together to get the mass of the compound. So for this one, the compound, if I add these together, I'm going to get that this is 17.6 grams. So I added it together. That is my mass of my compound. And so let's go ahead and start the process of getting the percent by mass. So here we're going to divide by the compound. So 17.6 grams multiplied by 100. So if I do 14.4 divided by 17.6 and multiply that by 100, I'm going to get that this is 81.8%. Okay, we're going to do the same thing for the hydrogen. I kind of ran out of room here. 17.6 grams multiplied by 100. So let's do 3.23 divided by 17.6 times 100. And so I get okay, so that's going to end up being 18.4. If you add this together, you're going to get 100.2. So it is off just a tiny bit, probably because of rounding and sig figs and things like that. That's okay. We just want it to be very, very close to 100, realizing that we are going to run into a little bit of an issue just with rounding. But everything looks good. If I had not taken 3 sig figs here, then it would have been off even more. You could, if you wanted to, probably take 4 sig figs here and then round at the very end. You can try that and see if it's a little closer. As far as sig figs go, what I'm really going to be grading is this last number right here. So when you get to that very, very end percentage, does it work with what you need it to be? And like I said, for the future, these numbers, I will make sure that they have 3 significant figures. Okay? Okay, so that should be everything. If you need me or if you have a question, you're more than welcome to email me and ask or come in during tutorials. Have a great evening.